Real number chapter 1 exercise 1.1. So what's the first question here? Use Euclid's algorithm to find HCF of the following. As we have already seen such type of questions in the previous video, let's do some here. So the given numbers are 1651 and 2032. Let's take the bigger number first, 2032. How can we open it as 1651 into 1 plus 381? Now again, taking 1651, open it as 381 into 4 plus 127. 381 again is equals to 127 into 3 plus 0. So what was the process of doing that? A is equals to B cube, A is equals to B Q plus R, right? We should do until we get the value of R is equals to 0, and the value of R should not exceed the value of B, right? So the HCF is 127. Let's see one more here, 196 and 38220. Let's open 38220, the biggest number first, as 196 into 195 plus 0. We got 0 in the first step. So HCF is 196. And moving on to the second question. Use a division algorithm to show that any positive integer is in the form of 6q plus 1, 6q plus 3, 6q plus 5. Okay, just like bq plus r, right? Where q is some integer, obviously integer. Q could be any integer 1, 2, 3, 4 and so on. So how are you going to do that? Let a be the positive add integer. So let's just suppose the integer to be a instead of, it could be any integer. So now let us apply division algorithm with a and b is equals to 6. So why are you taking b is equals to 6 here? Because we have this here, right? 6q plus 1, 6q plus 3, 6q plus 4. In all of those, which is in the form of bq plus r. So the value of b here is 6. That is why we are taking the value of b as 6, right? So now what should be the value of r here? When we take the value b is equals to 6 means then r should be lesser than b, from 0 to b, right? From 0 to less than b, which can be till 5. So the value of r are 1, 0, 1, 2, 3, 4 and 5, right? That is, a can be expressed as 6q, means bq plus r means 6q plus 0 will be 6q, right? I'll just write and show you once. If we take 0 as 6q plus 0, then the answer will be 6q, right? Similarly, if we take 1, 6q plus 1, if we take 2, 6q plus 2, if we take 3, 6q plus 3, 4 and 5. So where the q is quotient, obviously q is quotient, but a is taken as an odd number. The question, it's here, it is given as odd, which I missed to write, so that is why we had mentioned odd. So it's asking, the question is asking odd positive integers. So even we should remove the even. Let's remove 6q, 6q plus 2, 6q plus 4. All the evens are removed. So the odd positive integers are in the form of 6q plus 1, 3 and 5, because the question is asking odd. Moving on to the next one. What's the next question? Use division algorithm to show that the square of any positive integer is in the form of 3p or 3p plus 1. So now what comes here is the new thing we got, that is square, right? So this is square. Power 2 is known as square. Everyone knows that. Let a be a positive even integer. This a is in the form of 2p. Instead of 3p and 3p plus 1, we are supposing as 2p and 2p plus 1. So because he is asking square in the question, we are going to square it. A square is equals to, let's first take 2p, okay? 2p whole square, which is equals to 4p square. If we take 2 common here, then 2p square, right? So let us consider this 2p square as k. Let me just circle it so that you can understand better. 2p square can be considered as k. So instead of writing 2p square, we will write 2k, where the value of k is equals to 2p square. It's an even integer. If it is an odd, then what are we going to take? 2p plus 1, right? For even we took as 2p, for odd we took as 2p plus 1. Let's square again. A square is equals to 2p1 whole square. So what's the formula here? A plus b whole square. A plus b whole square, which is equals to a square plus 2ab plus b square. So who's a here? A is 2p, which is equals to 2p whole square plus 2 into 2p into 1 plus 1 square, which turns as 4p square plus 4p plus 1, right? This is what we got here, 4p square plus 4p plus 1. Let's take 2 common from these two things. From 4p square and 4p, let's take 2 common. So what's remaining is 2p square plus 2p, then plus 1 as it is plus 1. Now, just as before how we considered 2p square as k, we'll consider 2p square plus 2p as k. Let's consider this whole value as k. Okay, so what could it be? 2k plus 1, right? So 2k plus 1, where the value of k is equal to 2p square plus 2p. And odd integer, we got one even integer and we got one odd integer. So it is satisfying the equation which includes all positive integers, whether they are even or odd. If it is satisfied with 2p, then it can also satisfied with 3p. So now applying Euclid division lemma, where a and b is equals to 3 as given in the question, it could be 3p, 3p plus 1, 3p plus 2, because it should be lesser than 3. So where p is the quotient and 0, 1 to 3, 0, 1 and 2 are the possible reminders. A can be considered as square of an integer. Therefore, any square is in the form of 3p and 3p plus 1. As we have already seen, even also satisfied, odd also satisfied. So, any square also satisfies 3p and 3p plus 1. So, the next question is, use the division algorithm to show that the cube of any positive even integer is in the form of 9m, 9m plus 1, 9m plus 8. Just as before, there was square, now we have cube, the power 3. Okay, so let a be the positive integer. Then from Euclid's division lemma, so who comes in the picture? Exactly, a is equals to b cube plus r. Now consider b is equals to 9. Why? As it is given in the question, 9m, 9m plus 1, 9m plus 8. Yes, exactly, 9, 9, 9. So b is equals to 9, bq plus r, bq plus r, right? Then what will be the value of r here? From 0 to 8. 0, 1, 2, 3, 4, 5, 6, 7 and 8. So a is equals to bq plus r. A is equals to 9q plus r, because the value of b is equals to 9. So a cube is equals to 9q plus r whole cube. 3 is missing here, the cube is missing. Okay, so what's the formula of a cube plus a plus b whole cube, right? This is a, this is b, and this is whole cube. So what's the formula here? Formula is a cube plus 3 a square b plus 3 a b square plus b cube. So we will elaborate this into this formula. So how are we going to that? 9q and r are a and b whole cube, right? So 9q whole cube means a cube plus 3a square b, 9q whole square b, because a is 9 and q together, so that is why it's whole square. b plus 3ab square is 9 cube. So 9 cube and q cube, let's separate it. 3 into 9 square q square are separated. 3 into 9 into q into r square separated plus r cube. Okay, so let's take 9 common from all of these. If we are taking 9 common, we got 9 square q cube plus 3 into 9 into q square into r. We are taking 1 9 out of here, so we got it here, only 1 9 left. From this we are taking 9 common, so there is no 9 here, just q and r square and r cube as it is. So the Euclid's division lemma turned into a cube is equals to 9m plus r cube. Okay, so now the value of m is considered as this. Just as previous example, we took the value of ke, right? Just like that, we are taking here m as whole of this. What were the value of r? 0, 1, 2, 3, 4, 5, 6, 7 and 8. If r equals to 0, let's take the first step with the value of r equals to 0, then r cube is equals to 0 obviously. A cube is equals to 9m plus 0, which is equals to 9m. So here the value of a cube is 9m. Let's take 1 now. R is equals to 1, r cube is equals to 1, then a cube is equals to 9m plus 1. So what do we got? 9m, 9m plus 1. That is what it is asked in the question. We got 9m, 9m plus 1. Now we also need 9m plus 8. We need only these three forms. We don't need any other forms apart from these. We have to show that the cube of any positive integers in the form of 9m, 9m plus 1 and 9m plus 8. So no matter what answer you get, you need to turn that answer into 9m, 9m plus 1 and 9m plus 8. Now the value of r equals to 2. So r cube is equals to 8, right? 2 into 2 into 2 is equals to 8. Then a cube is equals to 9m plus 8. That's it. We got 9m plus 8. So we are going to do further while taking r is equals to 3, 4, 5, 6, 7 and 8. Let's see what answers we get. Now when r equals to 3, r cube is equals to 27. 3 into 3 into 3 equals to 27, right? Then a cube is equals to 9m plus 27. Let's take 9 common. So what's remaining here? Let me just write and explain. 9 into 3 equals to 27. Let's write 9m as it is, which is equals to 3 into 9, right? 3 9 is 27. So let's take 9 common from both of these. So we are getting the answer as, when we take 9 common from both of these, m plus 3, right? Because this 9 goes in, 3 into 9, 27. So 9 common, m plus 3. Just how we do with the previous questions. Let's consider this value m plus 3 as m. Again we got 9m, right? Because we only need to do in the form of 9m, 9m plus 1, 9m plus 8. So it can be written as 9m. Next, if the value of r equals to 4, means 4 cube, 4 into 4 into 4 into 4 equals to 64, then a cube is equals to 9m plus 64. 9m plus 63 plus 1. So why are we taking 63 here? Because everything should come in the table of 9. 64 doesn't come in the 9 table because we need to take 9 common, right? So what comes in 9 table? 63. 7 9 is 63, 9 7 is 63. I'll show you how we're doing it. 9m plus 63 plus 1. 9m plus 7 into 9, right? Plus 1. So we are taking 9 common from this and this. Let's take 9 common. It's m plus 7 plus 1. So it is in the form of, let's take this as m, 9m plus 1, right? This is how we are going to do this. We need to take it in the form of 9m, 9m plus 1, 9m plus 8, right? So it cannot be 9m. So it can be 9m plus 1, right? We got 9m plus 1, where the value of m is equals to m plus 7. Moving on with the value of r should equals to be 5. We have to move on till 8. So 5 cube is 125. Find into 5 into 5, 125. A cube is equals to 9m plus 125. Just as we did in the earliest question, 125 doesn't come in 9. So let's take it as 117 plus 8. Open this 125 into 117 plus 8. Let's take 9 common. 9 into m, 9m. 9 into 13 is equals to 117. You can do it on the rough column. Plus 8 as it is. Now the value of m should be m plus 13. So it is 9m plus 8 in the form of 9m plus 8. On where the value of r is equals to 6. R cube, 6 into 6 into 6, 216. A cube is equals to 9m plus 216. So we need to elaborate 216. But wait, we don't need to, because 216 comes in 9 table, which is 9 into 24. It directly comes in 9 table. So let's just multiply it to check it out. 24 into 9. 4 9 is 36. 9 2 is 18, 19, 20, 21. 216, right? It comes in 9 table. So we don't need to do any addition of numbers. So 9m. The value of m is equals to m plus 24. Then it is 9m. It is in the form of 9m. Either 9m, 9m plus 1 or 9m plus 8. So it satisfies the form 9m. R equals to 7. 7 into 7 into 7 is equals to 243. Then 9m plus 243. Let's do it again. 243 does come in 9 as well. 9 into 27 is equals to 243. You can do the multiplication by yourself just to check it out. So again it is in the form of 9m, where the value of m is equals to m plus 27. Now the last one is r as 8. 8 cube is equals to 512. Then a cube is equals to 9m plus 512. Does 512 comes in 9 table? No. So which number comes in 9 table? That is 504. So we'll take as 504 plus 8. 4 plus 8, 12. 504 plus 8 is equals to 512. Let's take 9 common from these two. Remaining is m plus 56. Multiply 9 into 56, we'll get 504. So let's consider this whole m plus 56 as m. 9m plus 8. Therefore a cube is in the form of 9m, 9m plus 1, 9m plus 8, right? We proved it. Moving on to the last question of this exercise. Show that 1 and only 1 out of n plus 2, n plus 4 is divisible by 3, where n is any positive integer. So let's just understand the question first. What is it saying? When we are substituting values of n in n plus 2 and n plus 4, any of these three is divisible by 3, either n plus 2 or n plus 1, n plus 4, sorry. So how are we going to do that? Let any n be the positive integer. Same Euclid's division lemma. This thing comes again. bq plus r. Now consider the value of b is equals to 3, because it is saying divisible by 3. So let's take its value as 3, which is equals to 3q plus r. Again the value of r is 0, 1 and 2. We know the rule. So moving on, let's taking case 1 as 0. The value of r as 0. So n is equals to 3q. N is equals to bq plus r. N is equals to 3q plus r. Here the value of 3q is, here the value of r is 0. N is equals to 3q, right? So while taking n plus 2, 3q plus 2, n plus 4, 3q plus 4. So let's see, any one of this should be divisible by 3. Does n is divisible by 3? Of course. It's 3q divided by 3, right? 3 cancel, remaining q, it is divisible by 3. Now 3q plus 2, 3q plus 2 by 3, not divisible by 3. What about 3q plus 4? 3q plus 4, again not divisible by 3, cut it out as well. So only n is equals to 3q is divisible by 3. One satisfied from this 3. The value of 1. Let's see. 3q plus 1. Next, n plus 2. 3q plus 1 plus 2. 3q plus 3. N plus 4. 3q plus 1 plus 4. So it's 3q plus 5. Let's check which will satisfy here. First, n is equals to 3q plus 1. Let's take as 3q plus 1 divisible by 3. It doesn't. What about this? N plus 2. 3q plus 3 divisible by 3. Yes, it does. Let's take the 3 common. Q plus 1 by 3. 3 cut it out. We got q plus 1. Here we got q plus 1. Yes, it is divisible by 3. What about this? 3q plus 5? No. So this is also not divisible by 3. Here n is satisfied. Here n plus 2 is satisfied. 1 among 3. 1 among 3. Let's take the last number, that is r is equals to 2. 3q plus 2. N plus 2 is 3q plus 2 plus 2. 3q plus 4. N plus 4 is 3q plus 2 plus 4 plus 4. 2 plus 4, 6. Here, which one is satisfied? We can just say by looking at it, yes, that is n plus 4, because it's 3q plus 6 by 3, which is equals to 3 common, q plus 2 by 3, 3 cancel, which is equals to q plus 2, satisfied. So again, among from these all three, only one is satisfied. Therefore, any of the either n, n plus 2, n plus 4 is divisible by 3. It is proved. Here is 1 divisible by 3. Here is also 1 divisible by 3. Here is also 1. Any of the 3 is divisible by 3 in all the 3 cases. Proved. Thank you.